Hi, my name is William Fonseca. I'm going to present you today the work that me and João Paulo Ristow have developed with LabVIEW and National Instruments tools. Although this project is being applied to the NI Student Design Contest, we have been working with these topics during the last 3 years, more or less. So the project comprises different areas of science. For example, acoustics, the diffraction field, beamforming and array processing, genetic algorithm, software development, multithreading, instrumentation, and hardware. It's a joint project between two federal universities of the South Brazil. One is focused in the undergraduate program in acoustical engineering, and the other is concentrated in the master program in acoustics and vibration. Well, at first I will talk briefly about beamforming. Beamforming in acoustics can create literally photos of sound sources. Its post-processing is similar to a digital camera, but instead of light, it is sampling the sound field. So instead of a photo, it can offer a picture of the sound source. The technique has already been applied for external noise identification in aeroacoustics, for example, creating pictures which depict the radiation of the sound sources for each band of frequency and in different conditions. Here you can see the flight test configuration and the results of two airplanes. It's possible to see that the contributions are not only from the engine, but also due to the fluid structure interaction. The objective of this project is to also use the technique as a monitoring system, making possible the detection of sound sources in its surroundings. So we have worked from the fundamentals, that is, the equations, through the programming, and also in the instrumentation for the measurements. Now I'm going to talk about the software. We named it as WaveMap because essentially we are trying to map something. When you open the software, you will see the main VI. So the main VI is concepted to organize your files in form of a project and call each of the modules we have developed. As I told you before, the software was developed in a joint project between the Federal University of Santa Catarina and Federal University of Santa Maria. The software is also friendly with other developing tools, for example MATLAB, and there are quick links to open other software, for example MATLAB or maybe Fortran, and also the command window. I'm going to show you how to create a new project. It's very simple. You just have to go to the menu and new project, then name for a project, for example, let's say new project for now. And you also can include files from other measurements that you have already done. It's very easy. You just have to go to add files and select the file. Now we are going to add a previous measurement. Let's see. And that is it. Okay, you just need to add, and that's it. Your measurements included is in your new project. Also, an interesting, all the steps you do, they are recorded in the prompt window of the software and they are recorded. You can also open a previous project and let's see. Okay, and so your measurements, your plans, your geometry will be included. Another important thing is that the software has settings. There you can set your base path, your solver path, and your favorite number of cores. let's say, information about the model, the base speed of sound, and the path for external applications. Now we have MATLAB, Fortran, command window, and LabVIEW. So you can set and just press save. Now I'm going to tell you about the monitoring module. With this module, you can measure temperature and humidity. For example, if you need to measure sound pressure together with the temperature, you can set an external trigger. I'm now just doing example measurement. If you use the manual trigger, you just need to push start and stop when you want. You can also add information for the log, and when you push stop, it stops, and you can also save the file to a text file to use in other applications. I'm going to show now the optimization module, where you can use genetic algorithm techniques to find a kind of array. In this case, a circular array. So the tab control structure idea is to give an idea of the flow of the information. As you can see, you go from the left to the right. I'm going to do a simple demonstration using the fast fitness. In the fast fitness, we are not processing the beamforming itself. It is just an algorithm to test. When you push solve, then we start to see how the problem is solved, and you see the evolution of that. So in the next tab, in the results, you can see the geometries of one population, so the best individuals, and you can see also the fitness score of each one. You can see in different views, and that's it. Now I'm going to tell you something about the processing module, where you can process either measurements or synthetic data. In the first tab, you can do the project of the measurements, setting the sampling rate, and then you can get an idea of the total size that you need for an amount of measurements. In the second tab, you can configure your settings, and in the third tab, you can process the files from the time domain to the frequency domain. And in this step, we are using legacy software written in Fortran. As you can see, we have all the settings already set, so it's processing 2 files, and we keep track of the data logging of each file. So in the next tab, you get the information from the frequency domain and beamform them. As the previous tab, we have all the information already set, and then we process the cross spectrum files. Now I'm going to select just one, and you just need to push process, and that's it. Now you can get this file and input in the analysis module, or use in a different software to extract the data you need. I'm not going to talk about all the modules, so more information, they are in the document, in the PDF document included in this submission. So this chart is to give you an impression of the integration that you have implemented. As in the document, one of our intentions is to connect directly the BEM solver to the LabVIEW. So we are still working the next releases of the software. We cannot say that the software is beta. It's nearly the full version, but we are always implementing something new. We want to give a special thanks to some people, so family, friends, professors, and all the people that have supported this project. So if you have any question or anything you want to say, just email us. Thank you very much. Muito obrigado. Bye.